In this lecture we shall define what is meant by the source of a subset of the codomain of a mapping. If F is a mapping from A to B and B' is a subset of B, then we may be interested in the subset of the domain of the mapping, A, consisting of all those elements that map into B'. This subset is often referred to as the source of B' with respect to F. And it's denoted with an F by an F with a superscript left arrow applied to B'. It is defined as the set of all elements in the domain that map into B'. Let's illustrate the concept with a couple of examples, returning to our old friend the mapping F from integers to integers that first squares its input and then subtracts 1. The source of the set consisting of the integers 1 to 8 can be found by looking for points on the vertical lines through any of these integer points on the y-axis. If there is such a point, then the corresponding x value will be in the source. Thus, we find that the source of the set of integers 1 to 8 consists of the integers -3, -2, 2, and 3. The source of the empty set is always the empty set. Clearly, there is no element in the domain of a mapping that maps to an element of the empty set. The source of the set of natural numbers is the set of integers except 0, as you can see also in the graph. F maps every integer except 0 to a natural number. If we consider the mapping with the same specification, but now from real numbers to real numbers, then the source of the set consisting of the real numbers 1, 2, and 3 is the set of real numbers consisting of plus or minus 2, plus or minus square root of 3, and plus or minus square root of 2. You may want to pause the video to confirm that this is indeed the case. We proceed to formulate a general property about source that we can use in reasonings. Suppose that we have an element that is in the source of some set B', then clearly this element, F maps this element into B'. And conversely, if F maps an element into B', then it will be in the source of this B'. This idea is reflected by the property of source. It is a property that can be used in two directions. From x in the source of B' with respect to F, we may conclude that the F of x is in B'. And from F of x in B', we may conclude that x is in the source of B' with respect to F. Let's now investigate what happens if we take a subset A' of the domain of some mapping, compute the image under F of this A' as a subset of the codomain, and then return to the source of that subset. Now, as you can see from the picture, A' seems to be a subset of the source of its image under F. Let's formulate this as a general fact about mappings. Suppose that we have two sets A and B and a mapping from A to B, and we have a subset A' of A. Then A' is a subset of the source of the image under F of A'. Let's prove the statement, starting as usual with constructing a derivation for it, thereafter transforming it into a proof. The main symbol is the subset symbol. So we start the derivation with an application of the definition of subset. Our goal then becomes to establish that X is in the source of some subset of the codomain of F. A good opportunity to apply the property of source. Our new goal becomes to prove that F of X is in F of A'. We can now bridge the gap in our proof. We have that X is in A', and our goal is to establish that F of X is in the image of A' under F. This is achieved with an application of one of the two properties of image. Let's transform our derivation into a proof. Recall that the statement to be proved starts with a declaration of sets A and B, a mapping F from A to B, and a subset A' of A. The goal is then to show that A' is a subset of the source of the image of A' under F. In backward reasoning mode, first the definition of subset is applied. yielding the declaration of some x in A' for which it should then be established that it is in the source of the image of A' under F. The goal is then transformed using the property of source, and then the proof can be finished with an application of the property of image. We have proved that A' is a subset of the source of the image of A' under F. But what about the converse? Is it also the case that the source of the image of A' under F is a subset of A'? The picture already suggests that this is not the case. But we can be only really sure that this is not the case when we have constructed a concrete counterexample. Let's consider again our old friend f as a mapping from integers to integers that does squaring and subtracting -1. Now take A' to be the set consisting of the integer 2. Then we can compute the source of the image of A' by first computing the image of A', which is the set consisting of the integer 3, and subsequently computing the source of that set, which is the set consisting of the integers -2 and 2. Note that -2 is in the source because -2 also maps to 3, but it isn't in the set A'. We have found a counterexample consisting of a concrete mapping F and a subset A' of its domain, such that the source of the image of A' is not a subset of A'. We end the lecture showing again the definition of the source of a subset of the codomain of a mapping. We have discussed mappings as special kinds of relations and the notions of image and source. In the next couple of lectures, we will discuss special kinds of mappings.